Hello and welcome back again. As you know, today we are going to finish an important things. We are going to talk about important things, orbitals. That one is important because in Cal 1, Cal 2, we are going to depend on them, especially in the final exam. In the Cal 2 also, we have one chapter is dealing with the sequence and series. Most of them, or this chapter, chapter 10 in your Thomas book, actually depends on the idea of here. So for building your background, to make your background strong in math or in the Cal 2, you need all this information. And now we have what? We have a orbital. We have three types of a orbital. Am I right? Can you tell me which type we have? Yes. 0 over 0. So one of them is 0 over 0. So okay, 0 over 0. What else? Infinity over infinite. What else? Sorry? 1 over 0. No. 1 over 0 is equal to infinity. Or 1 over 0 is equal to infinity. Infinity minus infinity. Okay. Yes. Infinity times a number like that. A number, for example, 2, right? Okay, also this one is not is equal to infinity. Okay, what else? Finish. Infinite multiply infinite. Yes, you're right again. So infinite multiply infinite. Hello. What else?
Infinity multiplied by 0.
Infinite by 0. You are right. You are just guessing, or you know you read it. Infinite minus 0. No, you'll get infinite in that case. Infinite minus 0. Infinite? No. So infinite minus 0, no, is equal to infinite. Infinite plus infinite is equal to infinite. So how many types do you have? You just mentioned it, you didn't say anything. Look at yours. You can see this is the first formula. I'm going to give you the general idea, then later we are going to one by one. The first, for example, we have indeterminate form. We say indeterminate form. We have three groups of the form: 0 over 0 and infinite over infinite that you mentioned. It's a common, what do you say, common situation. We have infinite multiply 0, 0 multiply infinite, or infinite minus infinite. In that case, why we say indeterminate? Because we don't know is equal to what? We don't know. Maybe it's equal to 10, maybe it's equal to minus 10. We don't know. But when we solve, we get a result. Or we get nothing. So that's why we say indeterminate. Bari nadir. We don't know. The other one, if you see that this is the normal one. That one, the multiplication. And you can see the second one. And we have a power. What do you mean by power? Yes. So what do you mean? I know power is 1, but what do you mean? Indeterminate power. Number power infinite. No. 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 Let me see if we have it or not here. Yeah, you can see power here. Look at the example. I told you in the 7.3 that tomorrow we need that one. Do you remember that? So what's the problem with that one? Which type do we have here? You can see power. Well, that's why I say study. Did you solve this one? Do you solve this one? So I will not mention here. So we have what? We have power. Like what? 1 to power infinite. Not every number. Just 1 to power infinite. 2 to power infinite is equal to infinite. Half to power infinite is equal to 0. But 1 to power infinite, we don't know. Understood? Good. Which type of also power we have? 0 to power infinite. Am I right? Or infinite to power 0. So all these they are indeterminate form. Also 0 to power 0 or infinite to power infinite. These are also indeterminate form, and we can label them as a power of indeterminate. Understood? So the first one is easy, it's a common, we can solve. The second need a little bit of work. Maybe, for example, in that case, we need multiplied by conjugate. Maybe, I don't know. Maybe we use the, what do you say? Find or factoring, factor. Multiplying by conjugate, in that case. And the other, and these two, we are going to change to that formula sometimes, especially in Cal 2. We are going to change the first formula to the second, the second formula to be more easier to the second formula. Understood what I say? So let this map, this chart be in your mind, because actually we need them. Okay. Now we distinguish the chart. We draw the chart, we distinguish the types. So let me see what we have here. If we go directly with the subject. Okay, here we are. We have infinite over infinite formula. For example, I'm going directly to the example, and here's the theorem that we are going to use it without proof, you know. We have this example, look at here. 3x minus sine of x, limit of 3x minus sine of x over what? Over x when x approaches to 0. Understood? So how we solve that one? Exactly. First, as she mentioned, we need to substitute the value, because without that step, we don't know if it's indeterminate or not. Understood? You should write your reason why. Because if I substitute, I'll get 0 minus 0 over 0 is equal to 0 over 0. So now I'm sure about my problem, the indeterminate. Later, next, so I will have what? The limit still remains. So derivative of numerator, 3 minus cosine of x. How about denominator? Only 1. All right. Then what shall we do? Again, substitute 0. Thank you. Because careful, you have a note here. After each derivative, you should substitute. Don't say we have x to power 5. We need 5 times derivative. Careful. This is not right. Understood what I say? Não é que se tu ani pensa derivative you should, after each step, substitute the value. So in that case, I'm going to substitute, and I'll get what? I'll get 3, 1. So cosine of 0 is equal to 1. So as a result, I'll get 2. So from indeterminate form, we get the result. That's it. Easy? Do you have any comment? No. Yalla. Tell me about that one. 1 plus x. Okay, minus 1 over x when x approaches to 0. Okay. Yalla, which type? 0 over 0. Okay. Yes. Then, so derivative of numerator is equal to denominator is equal to 1. The derivative of here, this square root, is equal to 1 over 2, 1 plus x. Why? Because we get minus 1 over 2. We will bring it to down. Then the result will be limit of x approach to 0, 1 over 2, 1 plus x, or x plus 1. Okay, then we will substitute again the value. I'll get what? 1 over 2. Understood? Okay. So how about that one? If I apply 0, I'll get what? I will get 1 minus 1, 0. So again, 0. So you can see the indeterminate form, first type. So yeah, we apply L'Hopital, derivative of numerator, denominator. You will see this one is the first part of here. That one will be 0. That one will be 1 over 2. Here's the derivative. Then here will be 2x. Again, substitute. I will get what? 0. It's okay if you get 1 over 0. Careful. It's okay. If we substitute here, and I got something like that, 2 over 0, 1 over 0, anything. So the result I'll say is equal to infinite. Understood? But if I got indeterminate form, I should change it. So here we are. Again, if I put 0 here, I will get 1 over 2 minus 1 over 2, which is equal again 0. And here I'll get 0. So again, we should use L'Hopital. You can use how many times? You can use infinite times. But in each step, we should substitute. In each step, we should put the value, we should substitute the value. That's why you got 1 over 8. Any question about the third example? Hello? No question? Okay. Now, how many times we need the L'Hopital? How do you know 2? Why is not 3?
It's 3 because there's x to the power 3, so you have to.
But I gave you the note. I said don't think about that.
Yeah, but it's
So we don't know how many times. Actually, I don't know. We should do each step. That's why I'm asking you 2 times, 3 times. I told you, but because your mind say we have x to the power 3, so we need 3 times or 2 times. I don't know. We should do it. So x minus sine of x over x cubed, x approach to 0. I'm sure that about the first step, I will get 0 over 0. So I see is equal to x approach to 0, 3x squared, 1 minus cosine of x. If I put 0, again, I'll get 0 over 0. Am I right? Hello, dears? Good. So again, I'm going to use L'Hopital. So I'll get 6x. Okay. It will be plus sine of x. If I put 0, I'll get what? 0 over 0. So you are right. We got 0 over 0. So we have 2 methods to solve that one. The first, we have that formula. Do you remember that? We got that in the chapter 2. This is the first. So I can say is equal to what? Is equal to 1 over 6 multiplied sine x over x when x approaches to 0, and I'll get 1 over x, 1 over 6, right? This is the first method. Or here, for final exam, you can say here again, I'm going to use l'orbital, right? Up to you. أتواني بالفورمولا حاليكي؟ أتواني بوجاري سيم. Yes, that I shall agree. So I say is equal to what? X approaches to 0. أمام sine of x, 6 of x. Then I have a limit of x approaches to 0. Derivative of sine, cosine of x, derivative of 6x. Then I'll get 1 over 6. The same result. Up to you. Examine the next one. Say do you answer? أبي همو step dynamo. Otherwise, you'll get mistake. Yes. Amen. يعني مسلم. طبعا. Later, I'm going to share that one with you, this PDF. Be careful. Apply L'Hopital's regular correctly. What do you mean by that? So 1x minus cosine of x over x plus x squared, x approaches to 0. As I told you, because maybe it's x to power 2, you think we need 2 times L'Hopital. I don't know. We should apply them. If I put 0, I'll get 0 over 0. Now, how we solve that one? Paper and pen, please. So I'm going to solve that one. I c is equal to x approaches to infinity. Wait, derivative of denominator, 1 plus 2x. Derivative of 1 is 0, so I'll get sine of x. I'm going to again substitute. Again substitute. So sine of 0, 0. 0, if I put 0, I'll get 1 over 0. So it means that 1 over 0. 1 over 0 is equal to what? So it's okay. Sorry, 0 over 1. So I'll get what? Sorry. I'll get 0. So it's no problem. I'll get, the result will be 0 over 1 was equal to 0. It's okay. Even I got 1 over 0, for example, it's okay. I'm going to write infinite. Leave it. But it's not indeterminate. You cannot use the second. So if you did a mistake, you use the L'Hopital again, you'll get what? 1 over 2. Am I right? So the result is 0. But if I use here again another L'Hopital, I'll get what? X approaches to 0 cosine over 2, and I'll get 1 over 2. It's not correct. Okay, dears? Okay, good. كم كانوا غلطي كردوا زورينتان راسا حسبوا. Thank you. So most of the students got the point. Now here we are, and he mentioned that was equal to that one. Okay. I think that one is easy. I think that one also is easy. But we have x approach to positive and negative part that does not make a sense. Anything that you have, you can apply L'Hopital. If so, side limits like right and left side, if we have a direct or infinite or anything that we have, so you can apply it. Now, that one is what? The second type, right? The second type, we have 0 multiply infinite or infinite infinite multiply 0, or we have infinite minus infinite. I know he write here, but it's okay, you can count it with the first part. Now here we are. And you say what? You can change it of 0 over 0. Here's the first example. Now we have sine second. We have what? So second type. Second type. We have what? We have limit of x approach to pi over 2. Okay. Second of x, 1 plus. It was 1 plus or 1 minus? 1 plus, okay. 1 plus 10, okay, good. Now tell me is equal to what? Now you should use the table. Do you remember the table of the value? So pi over 2 is 90. Second is equal to sine, right? Second is equal to what? 1 over sine. Sorry, 1 over cosine. So it means that I have in my mind 1 over cosine. Here I have sine over cosine. Understood? Okay. So you can use also the idea of the graph. For example, I see tan equal to like that. Here's the asymptote. So here's a pi over 2. When I'm going, that's why I'm write down small, because we mentioned that one a lot. Here's tan. Here's asymptotes. Here's this is pi over 2. I'm going to pi over 2 from right or left side. Yes, from, for example, left side, I'll get what? I'll get what? Infinite. I'll get infinite. So here we have 1 plus infinite. Understood? And also I have a second. Here's the second graph. Here's pi over 2. Here's 1. When I'm going to pi over 2, again, I'll get infinite. That's the first method using the graph. I told you the graph is very, very important. Later we will use it. Now we use it. And before also in the previous chapter we used. So I got infinite over infinite. That's the first one. The second way, using the table that I gave you, I remember that. I gave you that. We say I have a here theta, sine, and cosine. We use pi over, we start with the 0, pi over 36, pi over 6, pi over 4. Do you remember that? And we see we have what? We have square root of, square root of, square root of. We put 0, 1, 2, and go on, and we put 4, 3, 2, and go on. You remember that? So in that case, pi over 2 will be here. Pi over 2 is here. So this point is equal to what? Is equal to 1 and 0 and 1. Sorry. 0 over x, 1 over x. So it means that cosine is 0, sine is 1. Understood? Now I have what? I say limit of x approach to pi over 2. Okay. Second is equal to 1 over cosine, means that 1 over 0, because here's a cosine. Also, I have what? 1 over tan of x, means that I have 1 plus 1 over 0 again, because tan is equal to sine over cosine. Both are the same. So in both cases, I got what? I got infinite over infinite. Understood, dears? Shall I repeat it? By the graph, I can imagine. By the value, you can substitute. Easy? Good. Yes, circle like maybe it's not pi over 2, maybe here, yes. You can use both, because the last of the here it was pi over 2. from 0, pi over 6, pi over 4, pi over 3, pi over 2. You can use both, up to you. You can use that one, or maybe the angle is changed. I changed to something else. You are right. But here, yes, this one is more common. This is more functional, actually. We use it more. Any question? So you can use the circle, you can use the table, you can use what? You can use the graph, up to you. Now it's your turn. We got infinite over infinite. So how we fix this problem? Yes, same way. So, yes. Yes. I know the orbital, but they give me the derivative. So it's equal to, sorry, not infinite, pi over 2. Wait. Can you put the mobile down, please? Yes. Hello.
7 is equal to derivative of 7 is equal to second times tan.
Okay. So wait. So we have second of x, tan of x. Maybe in your mind you see I made it more difficult, but maybe later you'll get something else. So derivative of denominator, Mustafa. Okay, bravo. 0 plus second square. Thank you. Thank you. We got second square here. Derivative of tan. That's why I say the other chain. You can see derivative where here is L orbital. So I will get what? I can remove that exponent with that one. Understood? Then I will get x approach to pi over 2 tan of x second of x. Any idea? Or just be patient, please. Yes. Okay, I'll get what? Tan of pi over 2, we say that. Infinite. Second of infinite again. Thank you. What else next? Wait. Sanaha. Next. Okay. You have to take derivative. Yes. Nani? Last name? Your name? Okay. So derivative. Yes. Okay. Let me do something else. Yes.
Can I say it? We have to do.
Yes.
Tan is equal to sine over cosine.
Thank you. Okay.
Sine squared.
So we have sine over cosine. Maybe there's something to do it. And here we have 1 over cosine. Why cosine square? No square, right? So this one with that one will eliminate. So I will get sine pi over 2. Sorry, sine of x. Why is that? Okay, so I will get what? Substituted, you'll get what? It's equal to. Understood? So can I show if you have trigonometric functions, they are together. Try to do your algebraic substitution, your algebraic factor, your algebraic, I don't know, cancellation. Understood? Maybe there's a common, maybe there's a cancellation. Good. That one, exactly, we have a question in chapter 10, no, 8.7, we have an improper integral. We should use that idea that I mentioned here. Like I told you, I was on review, you know, because I told you there we need it. Chapter 10, 8.7, I think, improper integral, also 10.1 and 10.2 till 10.5. I'm having to repeat a bit of idea. Okay, now x approaches to infinite. Another example. We have ln of x over 2 square root of x. Yalla. How do you know? You put it. So how do you know, for example, if there's some students say we don't know ln of x is equal to infinity, how we make them the clue? Yes. No. Tell me about that one is equal to what? Before derivative. That one is equal to what? Then x, no, it's a derivative. Just tell me. Yes.
Can you say by the graph?
Why not? How?
When you go to the positive.
Just show me how's the graph of ln.
It's
Yes, come on. Just by hands, you can do it.
goes through the one. When it goes to the positive, the answer goes to the positive as well.
Just sketch for me in the air, 3 dimension. Yes. Okay. Like that. You're right. Yeah, the person from in front of 0 to infinite. Just because I told you we need a ln graph. Do you remember that? It was previous lecture. So here we are. You are right is equal to infinite, but how? Show me. So like that. Now I'm going to infinite, and I gave you the limit of ln, right? I told you we need a graph, domain, range, limit. Do you remember that? Yes? Of course, the same. Yeah, you can say that, but how? Tell me the graph, something to be more clear. Yeah, prove it. So I know is equal to. During the exam, it's okay if you didn't prove that one, if you put the infinite over infinite for me. But you know, you have the information about this, but you haven't knowledge. You know what's the difference between information and knowledge? Do you know? Good. So that's the problem. I need to answer to get the. That's why I'm asking you to get the idea. You got it or not? I can see still you didn't get it. You know about the information, but you don't know how to make the knowledge. Because if you make it to knowledge in Caltech, everything is okay for you because you have an idea about it. Good. So here, if when x approaches to infinite, the graph is going to infinite. That's why we say is equal to infinite over infinite. Graphy error again, square root of x, again the same. They look like each other. So now I can do what? I can say is equal to infinite over infinite. Now we can apply L'Hopital's. Yalla. Yes. Okay, so here will be 2. Am I right? Why? Why is yeah? Okay, the derivative of here is equal to what? Yalla. Y equal to 2 square root of x. So y prime is equal to what? 2 1 over 2 square root of x. Am I right? No. يا باشا خلاص continuous. Sorry. No, you are wrong. Is that derivative good or not? What did I do? The same. I didn't do anything. But when I can wait, because during the look at the video, do not ask me where's that 2, why this 2 is in down. Understood what I say? Good. For me, it's okay. I know actually. Okay, good. So you have 2, 2. How about derivative of numerator? 1 over x. You're right. 1 over x. Easy. Because you got it. Then we have what? One over x. Okay. No, I'm going to write down like that. Look. Let me see if you get the idea or not. لا box. You don't need to. You know about that. Okay. I'm going to write that as here. Am I right? New idea for you. Okay. And I can say, am I right again? Yes. X is equal to what? Square root of x multiplied square root of x is equal to x squared is equal to opposite x. That's why. So I'm going to write down like that. Am I right? Now, what shall we do? Substitute. So it's equal to what? 1 over infinite Palamaka. 1 over infinite is equal to 0. So that's why I say is equal to 0. Understood? Easy, dear? Question. Yes? Sir, area for me? Yes. أو دوانو تشيليا. مش the same thing. wait. هسه أمامها A B مكاتة شيء. أنا مكاتة A B. يهربان كلهم ليش؟ يعني كانسلهم كلهم ديره. عملهم step again because some of you need. I don't care about that. You don't need it. But maybe someone, you know what I mean. I believe again how did you, right? You are right. The same thing happens. She said, why you are not canceling that too? Because I know they will cancel 2 over 2 is equal to 1 actually. But the other student maybe during the video say, where's that 2? How we deal with that one? So that's why we write that. Thank you. Anyway, do you have any question? Easy? You got it? Good. What else? Are you satisfied with that one? Look. E to power x over x squared. Another example. Another example. Limit of e to power x over x squared. It should be x approach to infinite to 0. Both are true. Is infinite. So e to power 0 is equal to what when x approaches to infinite? The graph is going to where? To infinite. Increased, right? So that's why I say is equal to infinite over infinite. Okay. So limit of x approaches to infinite. Derivative of numerator? X again. You are right. Derivative of denominator? 2x. Now again, I'll get what? Nothing changed, right? Another L orbital. I'll get what? Again x, but over 2. Now substitute, you'll get what? Infinite over 2 is equal to infinite. So it's okay. Right, infinite. Understood? Good. We'll take a rest, then later we'll back home. Back to here. Yes, not home. Sorry. We will back to the class. 10 minutes. Yes, Kaka, let me. The same. Here's. Okay. The same. The same. No idea.